All right, so this section focuses on the XBee Series 2 radio in the AT, also known as the transparent mode. Now, we talked about this in our introduction about the difference between the AT versus the API mode. I'm not going to go over that all again right now. And in this section, we are going to focus on a specific application. So we've already gone over the basics of the S2 radio, and I think that we can jump directly into an application. That application is going to be to transmit serial binary data between two XBee radios in the AT/transparent mode, and we're going to be using an Arduino to manage that communication. Okay, so what do we need to do? First thing we're going to need to do is purchase two of the S2 radios if you don't already have them laying around. Series 2 radios. You can't use Series 1 radios for this. You're going to need two of the breakout boards, and you're going to need at least one of the USB Explorer dongles. Okay, we're going to designate one as radio A. We're going to designate the other as radio B. Radio A is going to serve as the coordinator for the network. Radio B is going to serve as a router. Okay, we could also designate it as an end node because it's just communicating directly with the coordinator, but we're going to go ahead and designate it as a router. And then essentially the communication is going to occur between that router and the coordinator. Okay, so the first thing that we have to do is we need to configure both of the radios. We're going to do this in a way that's very similar to the steps that we used in the S1 Series 1 module. We are going to be using, again, the X-CTU application. We talked about that before. That's what we use to configure the radios. We are going to be using the Explorer USB dongle in order to connect them to the PC. And we're going to be using a similar set of parameters when compared to what we used previously for the Series 1. And so that's what we're going to talk about next.
Okay, why am I all the way up here in the XBee Series 1 radio section? Because I just said a second ago that you need to repeat steps 2 through 5 of that process. And so I wanted to go back to the notes from the S1 Series 1 module notes and just highlight what those are, which is, hook the XBee radio up to the PC, download and start the X-CTU application, run the X-CTU application, and then discover the radio module. Okay, so those are the steps 2 through 5 that I was referring to just a second ago. All right, so now going back down to where we are right now. Okay, we're in this section, Series 2 radio in AT/transparent mode. And like I said, it asks us to follow steps 2 through 5 from the S1 example. And so this is where we are right now. Okay, so we've added our radio A to, or we have found radio A using the X-CTU application. Next thing that we're going to do is configure radio A to ZigBee coordinator AT, meaning it's in the AT/transparent mode. And this is done by clicking Update Firmware, which is in the top right of the X-CTU screen. If you remember, this is the one I referred to as looking like a lighthouse next to a factory. So we're using a ZigBee radio. We want to configure it as a coordinator in AT mode, and we want the newest version of the firmware. Okay. So next, we want to click on our radio A. Okay. And we want to, and this is within the X-CTU software, I should clarify. All right, and you'll see that it provides you a serial number high and a serial number low, SH and SL. And so for this example, I give you the values here. Again, those radios are long gone, so there's really not too much to be gained from having access to those numbers. And you can see right up above, if my screen will scroll, that the serial numbers, well, they are located in this screen, but further up above. So it's listed above the AR, DD, NT, etc. You just have to keep scrolling up that way. And these will be static parameters. You don't have the ability to change them. They'll be grayed out. Sort of like the way that, let's see, that maximum number of transmission bytes right here. You can see this value is grayed out. We cannot update it. All right, next. Step number 6. We want to change the radio A parameters, and don't forget to write the radio settings. I only put that in there because I, on several occasions, have changed the parameters and forgotten to save the settings, and it doesn't really prompt you to ask you if you want to save, and so you can forget. All right, we're going to use the same personal area network ID as we did for the S1 example. This can be anything. I just use 1, 2, 3, 4. And then the other parameters. So right now, we're not going to worry about the other parameters. We're going to revisit Radio A's configuration before proceeding. So we consider this pseudo incomplete, our Radio A, right? It's not really ready for action yet. All right, moving on. You can see here that I defined the personal area network name, and right, that's pretty much it. Okay, so next, we are going to remove Radio A from the dongle, okay, and we're going to put Radio B on that dongle and connect it to the PC. So above here, we were working with Radio A, and below here, we are going to move on to working with Radio B. All right, so we stick it into the USB dongle, we connect it to the PC, we find the radio using the X-CTU software, and then we want to write down, again, its serial number high, SH, as well as serial number low, SL. For this example, these were the values that I got. And then we're also going to change the following settings, which I think is referring to this down here. It's a little bit funky. All right, so what settings are we changing? Our personal area network ID, that should match whatever we have written to Radio A. If they are not on the same personal area network, then you can pretty much, well, they're not going to communicate with one another. Okay, now, Radio B destination address high and Radio B destination address low. We are going to pull these values from those which we got for Radio A above, right? So this value here, well, I'll just circle both of them at the same time. Both of these values, so they end with a 00 and a 73, so let's make sure they match. If we go all the way down here, you'll see, all right, we have a 00 and a 73. Note, we are not using these values here, okay? We are not using the values for Radio B, okay? If we were to set the destination address for Radio B to its own address, you're essentially sending the packets to yourself. So we are going to pull these from Radio A. Okay, now that the SL and SH parameters are known for Radio B, we have to load Radio A once again within X-CTU and define its DL and DH parameters properly. So what we did a second ago was, okay, we pulled up Radio A and we acquired, can't spell, we acquired its serial number low and serial high. Then what we did was we moved on to Radio B. We acquired its serial number low, serial number high. We also set its destination low and destination high because we had those from up above. And now what we're going to have to go back and do is do the same thing for Radio A, which is set the destination low and destination high. And as you would expect, it's a crisscross. They should be referring to each other. Both of the radios should be using the opposite or the counterparts, serial low and serial high, as the destination low and destination high. And so you can see I pulled these two values and I use this one down here, and I use this one down here. So I know there's a lot of arrows, but hopefully because I'm talking through it, this all makes sense. And so you can see our settings inside of X-CTU. I think I've talked about most of this. Personal area network, changes, make sure the type of the radio is correct. Okay. Next, we remove radio A and connect radio B to the PC using the USB Explorer dongle. But at this point, we have completed our baseline configuration for both of the radios A and B. So now what we're going to do is move on to interfacing the XBee radio with the Arduino microcontroller, and we're going to talk about what role the Arduino plays. Interfacing the XBee Series 2 radio with the Arduino microcontroller. The user will need two Arduino microcontrollers with associated breadboards. I mean, I guess you don't really need breadboards, but it would make it a little bit difficult to connect things. And actually, I realized I didn't put this in the list of materials we would need above. I didn't talk about the Arduinos, but I'll try to go back and add that in. The breadboards will be used to mount the XBee radios and the corollary circuits. But this is still something you can gain a lot from, even if you don't have the materials right in front of you. All right, so this is step 11 because we're still continuing as part of the same process from above. Well, I guess there is no step 10, step 9. Oh, there we go, step 10 and step 11. So we are going to make the following connections for radio A, and I'm going to call the Arduino associated with it Arduino A. Now, Arduinos, before I move on. Right now, I don't have a section in the course that talks heavily about Arduinos. I think there's one small one that discusses it. So you do have to have some background on using the Arduino in order to understand this section below. Now, you can use the resource that I provide. There's also plenty of really good materials online. I'm trying to not go too in-depth in areas where there's lots of good materials already existing. So for example, not talking about Arduinos too much, but a lot of this other stuff, especially working with like XBee radios and the particle photon, some of the materials are a little bit less well formulated. Anyway, to make a long story short, if you are completely clueless about what an Arduino does and how to use it, you probably will need to go back and take a look at some materials on that topic before you move forward. All right, so we're going to make the following connections. So we're going to connect a jumper wire from the 3.3 volt terminal of the Arduino to both of the positive rails of the breadboard. And I'll zoom in on these pictures in a second. We're going to connect a jumper wire from the ground terminal of the Arduino to both the negative rails of the breadboard. And all that's essentially doing is these two steps is just stating that the Arduino is going to access power or pull power from the positive and negative rails of the breadboard. Okay. Next, we're going to connect pin 1 of the XBee VCC to the positive rail. Again, right, the positive rail is going to have our voltage supply, and pin 10 of the XBee, which is the ground, to the negative rail. So all we've done up until this point is connect the power for both the Arduino as well as the XBee. Now, next thing we're going to do is connect the XBee pin 2, which is the transmission / D out pin, to Arduino pin 0, which is the RX / D0. So the transmission pin will be connected to the receiving pin, and then vice versa. XBee pin 3, receiving D in, will be connected to Arduino pin 1, which is TX D1. So it's sort of a crisscross that you have going on. If you take a look at these pictures in more detail, you can see exactly all of the connections. So I show you the whole circuit, and then I show you zoomed in, sorry, it's going black, on the XBee, and then zoomed in on the Arduino. I use this version of the Arduino only because this is what I had laying around, and so it seemed like the best one to use. All right. So now we're going to do the same thing for Radio B and Arduino B, and that means all of the same connections. All right. Now, so we've connected the Arduino to the XBees. Is there anything else that we need to connect? Basic input and output circuits. We're going to keep this example as simple as possible. What we're going to do is we're going to connect a normally open switch between the positive rail of Radio A's breadboard and Arduino A's pin number 2. Okay, and so what that's going to do is allow us to, using that switch, toggle. You have so you have Arduino A, all right, and you have pin number 2, which is, if you look up here, oh, it's not included. Sorry, this would be our pin D2, and then we have our positive 3.3 volt supply, and then we have a switch in the middle. Okay, and so what we can do is put our finger right there and push that switch in order to connect 3.3 to that pin D2. And so this is going to allow us to change the input. We're also going to connect a 10 kilo ohm resistor between D2 and ground to ensure that the Arduino receives 0 volt when the switch is open. So we're also going to take this node right here and connect it to ground using a 10 kilo ohm resistor. We call this a pull down resistor. Okay. And so what we have is a system again where when we push the switch, pin D2 flies up to 3.3 volts. When we let go of the switch, it should drop down to 0. All right. Next, what we're going to do is connect an LED between Arduino B's pin 5, which is called D5, and ground. So that pretty straightforward. We have pin D5 of Arduino number 2, and we have an LED, and then ground, and right, we have light being emitted there. Now, I would draw circuit schematics for these, but I'm hoping, again, for the sake of efficiency, I'm trying to pare down as much as possible. So, I mean, these little drawings, I think, do a pretty good job of explaining your connections, and also, you know, the verbal or the written descriptions here. I'm hoping everybody understands. Okay, connect an LED between Arduino pin 5 and ground. Hopefully, everybody understands what that means. Okay, so next, we have our circuit set up. We need to now configure the Arduino microcontrollers using the build IDE in order to have it do what we want to do, have it issue the control signals that we want it to issue. And in essence, the Arduinos are going to be controlling the XBee radios. And this is how it is done in the AT/transparent mode. And next, we're going to talk about the API mode, which is a little bit different. All right. So now we're going to upload this code to Radio A. And this code simply tells the Arduino to generate a D on its pin 1 when the button is depressed. Okay, and I should probably clarify, we're uploading the code to Arduino A, not the radio itself. So I'm going to try to keep those clarifications clear. All right, so this is the firmware that we're uploading to Arduino A. What does it say? All right, and I do want to give credit to Rob Faludi. This is his website right here. Please check it out. I did not copy this word for word, so I hope that he will be understanding and me using parts of it, but it is heavily derived from that. So I do want to give credit. Please check out his website. Very great resource, and I used it really almost completely to learn this material. And I think he also has a textbook on this, which I will try to give a shout out to. Okay, so what are we doing here? We're defining that the button will be pin number 2. And that makes sense because we are using pin number 2, and that's where our switch is connected. Next, we are going to have void setup. We set the pin mode at button to input, and this is just starting the serial connection for displaying debugging messages. Okay, then we start the loop, and we say if we read the button and it's equal to high, then we're going to serial print a D. Okay, we delay 10 seconds, or actually I think that's 10 milliseconds, and then we start over and over again. So if you let go of the button, then it would no longer print that. You have Arduino A, and you have radio A, and you have Arduino B, and you have radio B. Okay, and so what we're doing is we're using the switch to supply a signal to Arduino A, and specifically to pin, to pin D2. All right, that information is then being conveyed to radio A using the, if you can see up here, the RX TX connections. Okay, then that information is being transmitted wirelessly, okay, between the two radios, and it's simply just a single character, all right, to radio B. That information is connected to Arduino B, again using the RX TX connection, and then Arduino B at pin number, let's see up here, pin number D5, then is connected to an LED, which is going to turn on and off when it receives that value of D. Okay, so we have discussed the firmware on this end. Now we need to discuss the firmware on the other end. What we're going to do is go down to step 14, and we need to upload the following pseudocode to radio B, the receiving end. And this code simply tells the Arduino to generate an output high on pin 5 when it receives an input of D on pin 0 RX. Now, again, this is not a course on Arduino, so I just included pseudocode for this one. I'm hoping that everybody will find that to be sufficient. Basic steps, right? We need to assign the pins RX and D5 to int variables so they may be accessed. This will be done within the setup part of the code. We then acquire the value from the RX pin. We check if that value is equal to D. If it does, then we're going to set digital write to our target pin, which is D5. And we'll set that equal to high, and that will fire off the LED. Otherwise, we set it to low, and that will cut off the power to the LED. And so you can take a look at these two figures right here. Essentially, it shows that it's working. And that should be all the information that you need in order to get this very simple example working. Again, where we are using the XBee radios in their AT/transparent mode, and the Arduinos are controlling the communication and what happens. Well, it's not really controlling the communication. That's not the best way to say it. What it's doing is it's controlling how the information is used, both pre, communication and post communication. Now, when we move down to talking about the API mode, we will not need these Arduinos, okay? Because we will be uploading the appropriate code, Python code, to our radio, and we can do some more interesting things there. But for this next example, we're not going to be using the Arduinos.